Behaviorism is also known as evolutionism or the cybernetism, originating in mid-20th century psychology. Behaviorism emphasizes the observation and measurement of observable behavior, focusing on behavior goal orientation and addressing feedback mechanisms to learn and adapt from the environment. Here are the key characteristics of behaviorism. 1. Focus on external behavior. Behaviorism emphasizes observing and measuring directly observable behavior, disregarding internal psychological processes. In behaviorism, the emphasis is on simulating and predicting the external behavior of intelligent systems. 2. Learning through feedback. Behaviorists believe that learning is formed through environmental feedback and rewards. Artificial intelligence systems adjust their behavior by observing or receiving feedback from the external environment to achieve better performance. 3. Emphasis on observability. Behaviorism rejects studying unobservable psychological states, concentrating instead on observing and recording measurable behavior. In behaviorism, there is an emphasis on inferring intelligent performance by observing the system's outputs and responses. 4. Building models for prediction. Artificial intelligence behaviorists use modeling techniques to describe how systems respond to inputs. These models are typically based on the relationship between inputs and outputs, without involving internal processes. 5. Emphasis on environmental adaptation. Behaviorism posits that individuals adapt and learn through interaction with the environment. In behaviorism, systems are designed to provide adaptive responses to environmental changes to achieve better performance and effectiveness. 6. Application to problem solving. Artificial intelligence behaviorists apply this theory to problem solving, especially in domains where performance can be assessed by observing and measuring behavior. Representative figures of behaviorism. Norbert Wiener. His book Cybernetics created a new discipline, control science, pioneering the behaviorist school in artificial intelligence. B. Pfeffer Skinner. Skinner is a significant figure in the field of behaviorism, focusing on animal behavior and operant conditioning. He proposed the theory of operant conditioning, emphasizing the role of the environment in shaping behavior. The main advantages of behaviorism include: 1. Practicality. Behaviorism emphasizes practical behavior and outcomes, focusing more on observable phenomena. This practicality gives behaviorist methods an advantage in solving real-world problems and designing applied systems, as they emphasize obtaining actionable results through observation and measurement. 2. Simplicity. Behaviorist methods are generally simpler, easy to understand and implement. They tend to avoid excessive theoretical complexity, emphasizing direct causal relationships, making behaviorism more manageable in some application scenarios. 3. Reward and punishment. Behaviorism highlights the impact of reward and punishment on learning and behavior formation. This emphasis makes it more intuitive and operational to introduce reward mechanisms and feedback in intelligent systems, aiding in the design of learning-capable systems. 4. Applicability to specific tasks. Behaviorist methods may perform well in solving specific tasks, especially in situations that require goal achievement through trial and error and accumulated experience. 5. Quantifiable results. Since behaviorism emphasizes observable behavior and results, it is easier to quantitatively assess the performance and learning effects of a system. This helps better understand the system's performance in practice. Major drawbacks of behaviorism. 1. Neglect of internal processes. Behaviorism advocates focusing on observable behavior while disregarding the individual's internal cognitive and thought processes. This leads to a lack of true understanding of the intelligence behind behavior, as behaviorism does not delve deeply into the study of thinking, perception, and inherent psychological processes. 2. Inability to explain complex behavior. Behaviorism has limitations in explaining complex cognitive and learning processes. The explanation of complex intelligent behavior requires consideration of more cognitive factors, and behaviorism struggles to provide in-depth explanations for these factors. 3. Inapplicability to creative and abstract thinking. Behaviorism primarily focuses on the direct relationship between learning and behavior, exhibiting weak explanatory power for complex cognitive activities such as creative and abstract thinking. 4. Dependency on the environment. Behavioral methods often rely on environmental stimuli and feedback. In certain situations, individuals may need to learn and make decisions in the absence of direct feedback, posing a challenge for behaviorism. 5. Excessive simplification. Behaviorism's simplification of cognitive activities may be too extreme, overlooking the complexity of information processing within the brain. This results in an oversimplification of the nature of intelligent behavior. 6. Inability to explain language and symbol processing. Behaviorism struggles to explain the mechanisms behind language and symbol processing, which are crucial for natural language processing and symbol processing in artificial intelligence. Overall, while behaviorism performs well in certain applications, it exhibits noticeable limitations in providing a comprehensive explanation and simulation of intelligent behavior. Behaviorism's major contributions to the field of artificial intelligence. 1. Foundation of machine learning. Behaviorism laid the foundation for machine learning. By focusing on the relationship between behavior and the environment, behavioral theory provided crucial insights into the learning theories of machine learning algorithms, fundamental concepts in machine learning, such as supervised learning. Unsupervised learning and reinforcement learning can be traced back to behaviorism's learning theories. 2. Modeling behavior. Behaviorism's approach encourages the modeling of behavior. In artificial intelligence, modeling behavior is a crucial step, especially in the development of intelligent agent programs. Behavioral principles aid in designing intelligent systems capable of adapting to and predicting changes in the environment. 3. Emphasis on the relationship between environment and behavior. Behaviorism emphasizes the impact of the environment on behavior, a viewpoint that remains significant in artificial intelligence. Intelligent systems need to perceive the environment and adjust their behavior based on environmental changes, aligning with the focus of behaviorism. 4. Foundation of reinforcement learning. Reinforcement learning is a crucial area in artificial intelligence, and behaviorism's emphasis on rewards and punishments played a positive role in the theoretical development of reinforcement learning. The basic concepts and algorithms of reinforcement learning are partially influenced by the behaviorist school of thought. 5. Practical success. Behaviorism has achieved success in practice, particularly in specific application areas such as robotics and autonomous driving. By modeling and guiding machine behavior, behaviorist ideas offer practical methods for these applications. Although behaviorism's standing in cognitive science has diminished, some fundamental concepts and methods in the field of artificial intelligence continue to be influenced by its principles. Control theory in behaviorism plays a crucial role in contemporary robotics development. Additionally, its evolutionary perspective has led to the development of practical algorithms such as genetic algorithms, evolutionary strategies, planning and ant colony algorithms. Introduction to the historical origins and development of symbolism, connectionism, and behaviorism in artificial intelligence. After introducing these three schools of thought, let's delve into their respective historical origins, development processes, and mutual influences. These three schools of thought began to germinate before the Dartmouth Conference, experiencing a period of incubation that shaped the development of artificial intelligence, each setting its tone and exerting its influence. Symbolism has a long and ancient history, tracing back to classical logic in ancient Greece and finding its modern roots in mathematical logic. Connectionism originated from contemporary physiological neuroscience. Control theory directly draws inspiration from behaviorism. Following the Dartmouth Conference, symbolic AI experienced significant development, overshadowing connectionism and behaviorism. As I mentioned in the History of Artificial Intelligence video series, the primary reason for this was the scarcity of hardware and computing power in the early stages of computer development. During this period, the computing power of the von Neumann architecture was a scarce resource, preventing researchers from constructing more complex networks or control structures in both connectionism and behaviorism, hindering the demonstration and development of these theories. After reaching its peak with various expert systems, symbolic AI revealed its shortcomings, primarily rooted in fundamental theoretical issues. Symbolic AI had essentially reached its limits, and only incremental improvements seemed possible. During this time, Moore's law facilitated exponential growth in computing power. Research in Connectionism and behaviorism gradually resumed, eventually entering a period of explosive growth around 2010. From Dartmouth Conference to the Big Bang of deep learning, the intertwined journey of symbolism and connectionism. From the Dartmouth Conference to the explosion of deep learning, approximately 60 years have passed, with symbolism and connectionism playing a continuous and alternating role. As a curious observer, I once likened them to the relationship between particles and wave theories of photons in physics. In reality, some heavyweights in artificial intelligence have made outstanding contributions to both fields. A notable example is Marvin Minsky, a prominent contributor to symbolism and a founder of connectionism. It was Minsky who, in his book Perceptrons, pointed out the limitations of perceptrons, directly leading to the pause. In connectionism research after 1969 and the rise and explosion of symbolism. In the previous section, we introduced these three major artificial intelligence schools of thought. To help you remember, I'll provide some vivid metaphors and their most intuitive differences. Symbolism simulates the human mind, encompassing logical reasoning, deduction, and abstract thinking in human intelligence. It has a solid mathematical foundation, and its processes and results are entirely explainable. Connectionism simulates the human brain, the biological neural system, specializing in perceiving, recognizing, extracting, and abstracting information from the physical world. While this perception currently focuses on vision and hearing, it can include various senses in applications. There is currently no perfect theory to explain the entire workings of the neural system. Although it is effective, no one can fully explain and accurately predict its outcomes. Behaviorism simulates human behavior, emphasizing perception, feedback, and control. It emphasizes learning from the environment and adapting accordingly, with a greater focus on application and bodily simulation. Behaviorism is more like an applied framework and a set of algorithms rather than a standalone theory. The limitations of these three schools of thought are evident. As intelligent as you are, you will likely conclude that a universal artificial intelligence must incorporate all three. This convergence is a hot topic in current AI research. By integrating these three major schools of thought and all possible academic achievements, we can make more progress in the theoretical development and practical application of artificial intelligence. In the end, I hope we witness the birth of general artificial intelligence in our lifetime.